I'm just going to rewrite the problem. Can somebody read it to me? Yeah, it's x to the 6, right? X to the, well, what? X to the 4th.
Minus 17x squared plus 16.
Okay. So what I'm going to do is I'm just going to go jump straight to the x. My first number is 1. That's my a. My second number is b. Negative 17. C is 16. So when I go to draw the x, 16 times 1 on the top and negative 17 on the bottom. Two numbers that multiply to give you 16 and add to give you, negative 1 and negative 16. Okay, so here's what's different about this way. I'm just going to rewrite the question so you don't get confused. Rewrite it again. Notice that this power is x squared, okay? It's not just x like normal, it's x squared. So when we break it down in terms of these two numbers, we have to break it down in terms of x squared, not just x. That's the difference between this and what we've normally been doing. Okay, so I'm going to take these two numbers, I'm going to break down this minus 17x squared, only it's going to be minus 1x squared, not just x, minus 16x squared. The power has to be the same. Okay, in other words, when I break this thing down, it has to be the same as this power right here. Okay, and then from there, it's just the same. You know, you're going to pull out a GCF of the first two. What's the GCF of x to the 4th minus 1x squared? Good. Pull out an x squared. And what are you left with in the parentheses? X squared minus 1. All right, pull out a GCF of the second two. This first term is negative, so it's going to be negative. All right, minus 16. X squared minus 1. And then so basically now we know that we've done it right because what we got in the parentheses is the same. So this right here is going to be the first factor, x squared minus 1. And then the leftover is going to be the other factor. I think I know which way you guys like better. The only caution I would say about this method is just make sure when you break this expression down, you make it the same power, okay? If you just put minus 1x minus 16x, it won't work. It's got to be power of 2.